All right, happy Thursday, ladies and gentlemen. Today we're going to introduce a new concept, so I wanted to make sure that I recorded myself explaining the new concept. So your Stephen. Your challenge questions are these challenge questions right here. I'm still seeing how well you compare fractions, subtract mixed number and a fraction, turn a decimal into word form, and then work on that challenge question, which is actually a question from a different version of the Unit 1 test. So that kind of helps you guys prepare for this end of the trimester test. So today we're going to talk further about decimals, okay? We're going to visually represent what a decimal is. So if you look up here, that entire bar is equal to a whole whatever, a whole bar. We'll just call it a whole bar. It could represent any hole in the world of anything. It could represent an entire video controller battery level, right? That is one full battery, and then every tenth of a battery it goes down, or every hundredth of a battery it goes down here. Every tenth of a battery it goes down here. And it says shade 6/10. Okay, 1, 2, 3, 4, 5, 6. There's 6/10. You can see 6/10 is also the exact same thing as 60 100ths, because the little tiny squares are hundredths because it's broken. 100 of them makes up the whole, and then the big ones are tenths because there's 10 of those big boxes that make the whole, and there's 10 hundredths in a tenth. Okay, so that's what the author of this book wants you to understand. The author of the book wants you to understand that 10 tenths are the exact same thing. 1/10 is the exact same thing as 10 100ths. And so he's visually trying to show you that here, showing you that 6/10 plus 2 hundredths is the exact same thing as going through and highlighting each 100th until there's 62 of them highlighted. So 6/10 plus 2 100ths is the exact same thing as 62 100ths. Let's look at that exact same idea looking at this number line here. The number line is labeled by tenths from 0 to 1. Whole. Okay. It's broken into 10 pieces. Each of those pieces are a tenth. Now it says begin at 0 and try to circle the distance to show 28 hundredths. So we could cheat and just do 2/10 real quick, because 2/10 is the exact same thing as 20 100ths. And we still need 8 more, right? We want 28 hundredths, just like a fraction, 28 hundredths of the whole. So there's 20 100ths. Now we just need to, if we broke that into 10 pieces, you would circle 8 of those pieces, right? If this between 2 and 3 was broken into 10 pieces, that would represent 8 of those pieces. So it says circle a new distance to show 74 hundredths. Okay, so I'm going to use an arrow here. There's 70, right? Because one entire tenth is 10 hundredths. And if you go 7/10, which 0.7 is 7/10, that is 71 hundredths. We still need 4 hundredths more. So now if we broke up between 7/10 and 8/10 into 10 pieces, then those would be 100th of the whole. We want 4 of those. So there is 74 100ths. The other way to do it is go take an arrow and go 70 100ths, which is the exact same thing as 7/10, and then go 7 more hundredths. So they're the exact same thing. 74 hundredths is the same thing as 7/10 and 4 100ths. Let's look at that yet again with this visual right here. So if you have 4/10 or 41 hundredths, they are equal to each other. They both have a 4 in the tenths place, but more importantly, 41 hundredths, just like a fraction, 40 over 100 is equal to 4 over 10. And if they were both fractions when we were comparing them, they'd be equal too. So let's visually understand that. Okay, 4/10 looks like this. 1, 2, 3, 4/10. So how could I show that in hundreds? Oh, I could literally do this 40 times. So 40 100ths is the exact same thing as 4/10. I hope you're getting the idea. Should we do it again? Let's do it again. So 36 100ths. It's the same thing as 30. There's 30. Now we need 6 more. But that's also the exact same thing as if I were just to take the entire row. Sorry, the entire row That's 1/10, 2/10, 3/10, and then there's still 6 100ths, okay? This one's tricky. So I challenge you to pause me and try to represent 1/1000ths on this grid. And I never have students that are able to do it right away. If you want to cheat, don't pause me and just watch the answer. The answer is, well, 1/1000th, if the smallest box here is 100th, we need to take that box and break it into 10 pieces. And when we break it into 10 pieces, highlight one of those pieces, because 1/1000th is 1/10 of 100th. 1/10 of 100th. You're taking a 100th. It's like taking a penny, because it's 100th of a dollar, cutting it into 10 slices and saying, this one little sliver here, that's 1/1000th of a dollar. All right. So today, what we are going to do, we are going to, all right, I didn't do this one here. It says use a sketch of money, a bar representing a hole, a number line, anything to show the statement is true. So if I did do this, you could show that on the left here is 3 dimes, because it's 3/10 of a dollar, and then on the right is 30 pennies. What's more, 3 dimes or 30 pennies? They're equal. Or you could draw a bar or anything else. Look at B. B, you have 7 pennies. I'm sorry, you have 7/100 or 1/1000th, which is 70 slivers of a penny. That is gross. That'd be gross to show. And then you have 7 pennies. 7 pennies is the same thing as 70/10ths of a penny. All right. So if you could fill that out in your math book, that'd be great practice. But if you paid attention to this video and you don't feel like filling it out, I'm fine with that. I think that our discussion right there was just as important as you filling it out. The idea is you are supposed to understand that tenths are the same thing as 10 100ths. Do you get that? And if you get that, great. We're ready to move on. All right, so equivalent decimals. We talked about that again. Why does writing zeros to the right of a decimal not change the value of the number? Because if 7's in the tenths place, it's 7/10. If you have the 0 after it, it's 70/100th. Same thing as 7/10. Well, if you have a 0 after that, it's 700,000. Same thing as 7/10. Okay, so those zeros after it, it doesn't change the value at all. Alphabetical order. Okay, so I threw this slide in here because today we are going to compare decimals. So we're going to put 2 decimals together, 2 different numbers, right? So like 1.1, 5.85. We're going to put those together and we're going to compare them like we would compare fractions. And the way I always tell students, it's as easy as alphabetical order. So if you looked at these 4 names, put them in alphabetical order. So what would be the first thing you do? Well, the first thing that you do, you guys already know, is you look at the first letter. So when you look at the first letter, which one's first? Which one is it would go first alphabetically? It doesn't change, right? They're all A. So we have to look at the second letter. When we look at the second letter, now things start to change. We see that Aaron or Aaron is going to definitely be the first alphabetical name. So we say Aaron's first, right? Now we look, we have N and M. Oh, N and M. So M is before N in the alphabet. So what we do is we're going to put Amber second. So Aaron's first, Amber second. Now we got Andy versus Andrew. You look at A-N-D, A-N-D. They're both the same. So now we got to go to the next letter. So one's R, one's Y. Oh, R is before Y, so that's third, and Andy's fourth. So we're not doing alphabetical order. This is math. You're right. This is math. So therefore, we're going to use the same idea with comparing decimals. It's that easy to compare decimals. So for example, the first thing I always tell students to do is when you're comparing decimals, the actual decimal is separating the whole amounts and the not wholes. Like if it's money, everything before the decimal is real dollars. After the decimal are cents. They're not worth $1 yet, right? If they were worth $1, they would add to the other side of the decimal. So the first thing you always do is compare the whole numbers. You should all be able to compare whole numbers. So when you compare the whole numbers here, you got 4 going against 5. Is there a clear winner? It does not matter what's happening with the decimals. If there's a clear winner in the wholes, boom, game over, flip. 5 is bigger than 4.9999999999999. Well, there's only 4 nines there, but you get the picture. So the first thing when comparing fractions is compare the whole number. If there's a winner, there's a winner. But what if there's not a winner? Good point. If there's not a winner, well, first compare whole numbers, right? Oh, Mr. Stahl, I compared whole numbers. They're the same, man. Well, now, just like alphabetical order, go to the first letter after the whole number, or go to the first number after the whole number. So go right after the decimal in the tenths place. If one of them has a bigger tenth, it's the winner. Does one of them have a bigger tenth? Yes. Therefore, we got a winner. That side's bigger. It's that easy. But Mr. Stahl, what if that's even 2? Okay. So we compare the whole numbers. We compare the tens place. Now compare the hundreds place. Now compare the thousands place. Oh, Mr. Stahl, Mr. Stahl, Mr. Stahl. This stops at tenths. See? It stops at tenths. There ain't nothing here, man. You're right. If there's nothing here, there's nothing here. You can write zeros until your mouse goes numb. I mean, your hand goes numb. You can keep writing zeros because there's no hundredths, there's no thousands, there's no 10,000s, there's no 100,000s, and on and on and on. So back to what we originally said. Now compare the thousands place. 1 is bigger than none. So therefore, winner. And that's it, ladies and gentlemen. That is all we're learning today. Is we are learning how to compare fractions. Compare the whole numbers. If they're a tie, go to the tenths place. If it's a tie, go to the hundreds place. If it's a tie, go to the thousands place. And in 5th grade, you don't go any further than thousands. But remember, like right here, don't get tricked. 700 thousandths is not bigger than 7/10 because 7/10 has no hundredths, no thousandths. So those are actually equal to each other. So your assignment today is you are going to work on the rest of that I'll give you the page. I don't have it right in front of me, but you're going to work on the rest of that page, and then we will talk about it tomorrow. Okie dokie. All right, I hope this video helped. We'll see you guys later. Happy mathing.